I must say this panel completely re-energized us, or at least me. We can go for another day, maybe? No, that's the final panel. And this next panel asks how artificial intelligence might serve the planet instead of simply extract from it. So please welcome the moderator, Mr. Yannis Mastrogeorgiou, General Secretary of Foresight in the Presidency of the Greek government. Yannis, welcome. Kalispera.
We have to do something with the slides. Every year the same thing happens with the slides. It's like an interrogation of the Lyceum Project. Thank you very much for being here today. I first of all want to thank Vangelis Karkaletsis and Alexandra Mitsotakis for making this Lyceum Project for a third year in a row. You are doing an amazing job, you and your teams and your colleagues. Well done, guys. Thank you very much for this. Now, I will use my written notes and then I will switch to my mobile and go vice versa. As it was mentioned, I am the Greek Secretary of Strategic Foresight, and I also lead the Greek AI, let's say so, team. And we made a concrete and concise national strategy report about a year and a half ago, with exceptional members within our team. Vangelis and Mr. Chekeris are on board here. And we presented to the government and to the Prime Minister, who was here a couple of hours ago. And in foresight, I don't know if you are aware of the term, our task is not to predict the future. We cannot predict the future. Nobody can predict the future, but to prepare for it. So to move from being reactive to be the architects of our long-term resilience. And today we address, as it was mentioned, a critical duality, which is AI for the planet and AI from the planet. We stand, it was mentioned many times, this today is here in Athens. We stand at unique crossroads, and of course, artificial intelligence offers unprecedented capabilities to model climate change, optimize renewable energy, and protect biodiversity. That is AI for the planet. Yet, we cannot ignore the other physical reality, which is how to train these massive models, which demands immense data centers, water for cooling, etc., and rare earth minerals. That is AI from the planet. So the technology we rely on to save our environment is inherently bound to the consumption of its resources. And coming from Greece, a nation and a tradition which is deeply rooted in the philosophical tradition of metron, which is the golden mean, we deeply understand that technology without governance is a risk we cannot afford. And our goal cannot simply be rapid technological growth. It must be wise governance that ensures AI remains a net positive partner for Earth's ecosystem. So to untangle this complex relationship and not to bother you anymore with my stupid words, and to map our next decades, we are joined by an exceptional group of experts, and I like to call Mrs. Radia Funa to be the first among us. Mrs. Funa is founder and CEO, Build and Blaze, inventor of WARE, and UN Special Advisor on Digital Technologies. Of course, is many more, but I will skip that for now. You are aware of that. I also like to please invite to the panel Mr. Uday Kemka. Welcome, sir. Mr. Kemka will talk to us a bit about the Green AI Learning Initiative, that is a global and multi-stakeholder network designed to unite academia, industry, philanthropy, investors, and many other things. Welcome, sir. And of course, my dear friend, Dr. Stelios Karosis. Where are you, Stelios? Καλώς ήρθες, Στέλιο. Καλώς ήρθες. Stelios is a prominent member and researcher at the Demokritos National Center for Scientific Research. I know him for a couple of years. We work together. He's an amazing guy. So, ladies first, okay? My question, we see, where is my question for you? So, the first question for you.
Okay. Okay.
I talked a little bit about that before. We all heard it these couple of days. Everyone now talks about AI and its environmental footprint. Mm-hmm. But how much do we actually know about artificial intelligence, energy, water, carbon, hardware consumption across its full life cycle, and what are the biggest blind spots in today's measurement practices?
What was the last part?
Mm-hmm.
What was the last part?
Which is, what are the biggest blind spots in today's measurement practices?
Gosh.
Yeah,
so
it's going to be a tough one. Sorry
that's
for
a
that.
small question. Thank
yes, it
you.
is indeed. With the use of AI, you can make it.
Well, first I want to start by thanking the organizers, the sponsors, the amazing audience for just making this space possible. I really appreciate it. I have really enjoyed the program thus far. I want to start in responding to your question with where I sit. Because I think vantage point matters. We talked about diversity. I work at the intersection of 3 layers: inventing measurement tools, architecting the international standards that govern their application with a friend of mine, Katie, and advising national governments on what responsible AI adoption actually requires on the ground, like what you're doing. The short answer is we don't measure AI. Not really. We don't yet have a reliable, independent, globally agreed on way to know what AI is actually consuming, not at the level of rigor that you're talking about, that governance requires. There's been great progress. So yesterday, for example, Google was talking about some of the work that they've done. Leading AI organizations are publishing environmental reports. We've seen several in the last year that are more detailed, more transparent than anything we've seen before. This represents a real shift in willingness to engage with the question, but transparency about one's own systems, measured by one's own methodology, is not the same as independent measurement. And without independent measurement, I would say there are 4 things we cannot do. We cannot compare across organizations. So I can't say what Google is doing versus Microsoft, versus NVIDIA, versus any other organization, because everybody's calculating this differently. It is the world we live in now. Secondly, we can't verify independently. There's no external audit layer. Thirdly, we can't measure, and this is super important, cradle to grave, the full life cycle, from the creation of that chip, or rather, the extraction of the rare earth from the ground, to the recycling, we hope, of the hardware. We can't measure that because we don't have that right now. And critically and finally, we cannot attribute consumption at the workload level. So what this means, what this specific task, this specific AI job consumed on this specific infrastructure. That is the atomic unit of accountability that enterprises, governments, and regulators actually need, and we don't have that. And then there is the systems dynamic that gets lost in what I call the per-prompt efficiency headlines. Aggregate consumption is still rising dramatically, even as efficiency per query, per one prompt, is improving. That efficiency at the component level does not substitute for accountability at the systems level. That's the space we're in right now. I'll leave it there, we'll get into more.
Yeah, we'll get into more details, yes, of course. So, Mr. Kemkam, through Grail, which is what you are doing, and what, first of all, would you like to comment on what you heard previous?
On the previous comment, I'd say it's absolutely critical that we think through these things, and congratulations on your leadership in that area. But before I respond, I will also reinforce my very great thanks to the visionaries behind this conference and for this fantastic conference. It's been, I was calling it mind-bending, emotional, ethical, spiritual, and technological yoga from my point of view. Extraordinary, and thank you very much for having me here in this amazing conference. I would say, obviously, the environmental impact, forgetting about the social impact we heard about earlier of AI, we're just in the infancy of figuring it out, as you correctly said. There have been, however, attempts to estimate at an aggregate level what the balance might look like between the extra data center emissions, just focusing on emissions, not water for a minute, and the benefit from the application of AI instrumentally to reducing GHGs. So Lord Nicholas Stern at the Grantham Institute, the LSE, for example, did a study last year estimating that by 2035, the extra emissions from data centers should be, it's a range between 0.5 and 1.4 gigatons of extra emissions. But the benefit was probably, in his estimate, or his team's estimate, likely to be 3.5 to 5.4 gigatons. But what's important to note there is that that emissions is related to a lot of uses for AI that have nothing to do with decarbonization or environmental applications. It could be cute kittens or whatever it is. So, you know, this thing is here with us anyway. The question is, how are we going to steer it for education or healthcare or fighting climate change?
That's the question.
Yeah.
You raised the question, answer it.
And the answer is, I bring the perspective not of an AI expert, but of a philanthropist who's been working on climate since the Earth Summit in '92. And after 30 years of work on tackling climate change, some of us in the early 20s, in 2021, COP26 in Glasgow, realized there was no hope in hell that we were going to make the IPCC's numbers of a 43% decarbonization from 2019 to 2030 within that time frame. And the only thing we could see that was J-curving at the speed or faster than climate was AI. And having interviewed more than 60 or 70 institutions that were AI companies, AI universities on one side, and very large emitting industries on the other, we came to the conclusion that these communities were not talking to each other. And so we brought together a summit about a year ago. I'm giving you the short version of the story, in London, in a partnership with the British government's Alan Turing Institute, Oxford and Cambridge and Imperial, King's, but also American universities and others, and NVIDIA, Google, DeepMind and others on one side, and big domains of utilities and transport networks and other huge corporate networks to explore this question. We broke it into real case studies for power generation, to accelerate renewable energy power generation, to balance the grid in the absorption of intermittent power, to deal with demand management problems, all of those things. And we found huge numbers of real companies, real solutions, real applications. And we found the same in the application of this to the decarbonization of the transport sector, the built environment, shipping, very strong for Greece, aviation, and verticals, one after the other. The next day, we looked at AI for the creation of new materials that could decarbonize, supply chain optimizations, carbon markets. And by the end of these 2 days, the 200 experts in the room were absolutely convinced that there was, it was an enormous plethora of AI solutions were emerging that could make a fundamental difference. After which, we created volunteer groups of experts in industry and created taxonomies of AI applications for the power sector, the built environment, materials innovation, and so forth, and then have worked with McKinsey since then to come up with scoping of all of that, and have entered into partnerships now with very large groups. I know this hasn't been the ethos of this summit, but a lot of emissions comes from industry and from the way capitalism works. So working with these very large emitting domains and going into partnerships now to accelerate innovation at tremendous speed and scale of AI applications to decarbonization pathways of the largest industries in the world. So for example, one of our partnerships is with an organization called WBCSD, whose 230 companies, all of which have net zero plans and are committed to decarbonization still in the current political environment, represent not only 24% of world sales and production, just think about that, $11.4 trillion, but 26% of world GHGs. That's almost China. With 230 companies accelerating their journeys down to net zero, we can impact quantitative GHGs on this planet. My country had 4 days of 52 degrees centigrade last year. 2 weeks ago, we had 53.4 degrees centigrade in northern India. And poor people are living in slum corrugated iron dwellings, 6 degrees centigrade, hotter inside than outside. They're living in 60 degrees centigrade.
Unbelievable.
So this is desperately important. It's not academic. I know it's instrumental, and some deeper themes of this conference have been wonderful, and that's where we're going to solve the problem in the long term. But in the short term, we have to catch up with a battle we're losing.
I'll get back to you. The nice thing with moderators and to be able to discuss with figures such as these prominent figures here, that they are very capable and they know what they're talking about, that it's relevant for me to be here because they get started by themselves and they speak because they know what they're talking about. But I have to justify my presence here, so I will raise one question to my friend Stelios. Stelios, you often describe AI as an optimization tool, but you have argued also that AI should help us to understand the world and not simply to manage it through algorithms. What is the difference, Stelios, between AI that optimizes systems and AI that deepens human understanding of the planet?
Okay. First, I'd like to thank you for your kind words and being here, the opportunity. Let's give a little bit of context. Okay. For the previous panel, maybe for my speech, the better word is not diverse; it's optimizer, optimize things. Yes. For my perspective, as for now, AI is used mainly to optimize processes, to optimize our daily lives, to help us do things faster. It's a first step, I know, but from the scientific point of view, it can help us save time. It can help us put a lot of data, a lot of dimension in a more understandable perspective. Visualization is very, very important for us, and give us time to discuss. The problem there is that many times, and imagine that you may train a new generation of scientists, use it as it is, and focus on just works, because it just works many, many times, and refrain from the context of why it works. Put out this kind of process that human society agreed on explore and study the planet and human nature based on find the first principles, ab initio research, basically. This is problematic. This is problematic because if we focus on only on it just works, we cannot find the causality chain between things in order to going forward and add to the human knowledge, of course, and also going to use AI for the planet and find, let's say, these climate hacks, if we focus on climate or environmental hacks, by understanding what is behind and find solutions based on that, and not only optimize things. This is, has a limit. We cannot optimize and, going to zero by itself.
Okay. Okay, nice. Back to you, Ms. Funan. You have referred to AI's attribution problem and the difficulty of knowing which environmental impacts belong to which AI systems, models, users, or infrastructure layers. Why is this attribution problem so difficult, and what would proper monitoring need to look like?
Thank you for that question. So first, I'd like to double back and just talk about the title of our panel, AI for and from the planet. Because you can't have AI for the planet without first knowing what AI is extracting from the planet. I started with what we know. Now let's talk a little about what we do with that knowledge, because I think that's where the architecture is built. There is a structural problem. The public conversation, what we mostly hear, swings between two types of per-prompt headlines. One tells you that AI drinks a bottle of water per conversation and implies catastrophe. We talked about catastrophe in the last panel. The other tells you that efficiency has improved by 33% and per query, and it implies that the problem is kind of solving itself. Both headlines are technically defensible, believe it or not. Neither, however, gives you what a policymaker that is setting national AI strategy or regulator that is writing disclosure requirements, or an investor that is deciding which AI climate application is worth funding, or a data center operator making real-time infrastructure decisions. It doesn't give any of them what they actually need, which is, like we talked about before, reliable, comparable, life cycle complete picture of what AI consumes relative to what it produces, as you were talking about earlier. The sensationalized headlines are unfair without context, while the efficiency headline is incomplete without aggregate impact. And here is what both miss entirely. Even as per-prompt efficiency improves dramatically, and it has, aggregate system-level consumption keeps rising. It's not a failure of effort, it's a gap with per-unit disclosure alone, because you need life cycle accounting, independent verification, and a unit of measurement that every organization can apply in the same exact way. So I developed something called AWARE. AWARE is meant to make it sound a lot more approachable, but what it stands for is AI Workload Attribution and Resource Engine, less approachable. It's the first independently developed technical framework for measuring what a specific AI task consumes from shared infrastructure, not estimates, as we have today, or averages, actual workload level attribution across energy, water, carbon, hardware, and performance. I also lead the development of IEEE P7100, which is the world's first international standard for measuring AI's full environmental impact across its life cycle. And the thread that connects this, and what I really was interested in talking about today, is how do we have this conversation, the same one that we're having, with data we can actually trust, independent data that is agnostic to whoever is being measured, again, not within their space. If you're looking at what makes it super difficult, is that at this moment we don't have, very simply put, a ruler. We can't measure it because we don't have a ruler, we don't have a way. The core problem is that AI runs on shared infrastructure. When a model processes a query, it shares the servers, the cooling system, the power with dozens of other workloads running simultaneously, and there's no existing tool that disaggregates that specific job that is actually showing you what is being consumed, not for energy, not for water, especially not for water, not for carbon. There's a little bit on emissions that you talked about earlier, and certainly not for hardware and waste. What I'm looking at now and what we published this month introduces exactly that mechanism, a way to attribute a workload's proportional share of any physical resource from a shared infrastructure expressed at the level of a specific job or a per 1,000 token processed under real operating conditions. Because right now, what we try to do, we often do in simulated or lab environments.
Thank you so much. Mr. Kemka, I have to ask you a question and not to let you comment, because then we don't have time for questions. Where do you see the most actionable use of AI for climate mitigation and resilience today? For example, in grids, in emission tracking, early warning systems, or adaptation? And which use cases are closest to real-world impact?
Well, so as I said, the difficulty in answering your question is becoming universal. Yeah. So let's think about what you were saying earlier. I would say there are 3 or 4 categories. One is detection. You have satellite. The oldest application was checking where methane was leaking. That could be done with satellite data. That was a kind of primitive application from a couple of years ago. This thing's moving so fast. A couple of years ago was like 10 years ago. So, but detection is important. And detection is the first way AI, across all these application cases, can make a difference. The second is prediction. So if you can predict, for example, what the wind pattern is going to be, I'll give you a simple example. You can fire up your gas backup station up or down, more or less. If you can optimize that, you can emit less fossil fuel emissions by getting the prediction right. So prediction is very important. The third is optimization, as you were saying. Think about the supply chain optimizations in terms of efficiency and the huge differences. One of the companies we had, it tracked 3.4 billion points of transmission and optimize routes. I mean, just think about traffic, optimizing that for emissions. There's a lot you can do with optimizations, just about any field. And then simulation, simulating new kinds of materials. Imagine a world of concrete without cement. This is not far away with 2D materials. And those molecules, just as AI is able to invent new pharmaceuticals or new healthcare, it's beginning to think about these new kinds of applications as well. So you see it everywhere. We found Arup, the construction company, talking about saving 17% emissions just in the design of water infrastructure or in the design of a building. So I'm afraid it's impossible to answer your question because the examples are now universal.
Thank you. Stelio, back to you. In climate science, deterministic models, stochastic methods, high-performance computing, and artificial intelligence coexist. Where do you see AI genuinely adding value to climate modeling and forecasting?
Okay. It's very interesting because what we think today about, we put together AI, it's this big data center machine, but at first, this kind of infrastructure was built for make simulation, deterministic simulation, and especially one of the first successful examples was the weather prediction, which is we don't think about in the 60s and late 50s. And it's a paradox that we try to replicate what all these kind of models, approaches that was very, very efficient of what they were doing. They were not abstract. Basically, you have the human intelligence, human knowledge and learning had, formulate very elegant equation describing nature and climate. Now we try to say we don't use that because the trend is AI. Let's, do everything with AI, which is on the opposite side because this has an environmental impact at the same time. But it's a learning process. How it goes right now, there's the main added value of AI nowadays about the climate research and the impact of climate research and how we can use it effectively and with positive impact is basically because these models, even if they are effective and efficient and can run fast enough, they cannot run at a time scale that can be operational in be used from civil protection for react as decision support systems in extreme events happening. So they go side by side. We can use them to data generation. It's physics, so it's more close to what it will happen. We don't guess, we don't extrapolate as AI can do, but we solve physics equation, that part. We can data generate, use it in AI training, and use AI in situation when we need an answer very, very fast, and with not as accurate as supported, but accurate enough to take decision. So, but for sure, keeping inside human in the loop. That's the main focus. Not use it as AI as not autonomous decision support system, but as a cognitive prosthetic, let's say, in what we are doing in those situations.
Yeah, I like that. Thank you. Back to you. What should organizations be required to disclose so that AI sustainability becomes real accountability rather than sophisticated greenwashing?
Real accountability rather than some greenwashing. I would say the disclosure challenge isn't primarily about organizations refusing to be transparent, I must say. The problem is structural. The structure goes back to something that I think was mentioned in the last panel, which is that organizations do say repeatedly that they want to be regulated. Our challenge, I think, especially on the international standards side, is let's give them what they want. If they're asking for it, give it to them. So without an internationally agreed on methodology, even the most detailed disclosures cannot be compared to one another. Let's make them comparable. But there's another element that inspired, if you don't mind, I'm going to go on a riff for a second, because I was really inspired by this conference to think back to my undergraduate Aristotle days. I think, if I remember correctly, Aristotle spent considerably amount of time on proportionality, and we were just talking about that. What does a good action cost? Just listening to the two of you, and is the benefit worth it? I think the question of whether a tool is worth using really has never been purely technical. And I think that is part of the struggle that some of the organizations that are driving. If you think about it, we call the AI industry an industry, but is it? Not really. It's what, 5 organizations that are driving this industry? And they're purely technical. But we're talking about an issue that is political, it's ethical, it's communal. And right now, we can't answer the question of what would even be disclosed rigorously, because when you're looking at conformity, so when a technology is going into society, first you would want to define that technology. And you know what? We have no globally agreed on definition of AI. So the first question you'd ask yourself is, what is AI? Before you go to, how can then AI be measured? And we can't measure AI on both sides of the equation, right? With any kind of real precision. On the cost side, the gaps we discussed: no workload attribution in operational production, no life cycle completeness, no cross-provider comparability, et cetera, et cetera, et cetera. But on the benefit side, we have no agreed on frameworks for measuring when AI actually contributes to climate modeling, to disease prevention or prediction, to the education of a child where there are no teachers. So what I will say is ultimately, what we are looking at is a governance question. I keep coming back to that, not just a technical one. It requires democratic participation, communities, governments, civil society, deciding what they value enough to spend their water on, their electricity on, their rare earths on. I think that's deeply political, and I think it's deeply philosophical. And I apologize, but I thought I'd riff a little.
Yeah. Apologies accepted. Mr. Kemker, you mentioned it before by saying an amazing example. Much of the climate burden falls on the global south, and while much of the AI capacity is concentrated elsewhere. So how can global collaboration avoid becoming another form of technological dependency and instead build genuine capacity and resilience in emerging economies?
Looking at AI structurally, I don't believe the global south is going to be competing at the level of fundamental LLMs. Let's be honest about it, right? You've got these two great giants who are battling it out. But when you then look one layer above to the application layer, where we can use this new technology, bearing in mind the trade-offs, to make a difference for education or healthcare or climate, there are going to be, not just the 5, because often they are platforms, but hundreds, if not thousands of companies and solutions, not even companies, scientific labs and universities here in Athens who will come up with great technologies because, to the previous panel, they have a relationship to the problem. They understand the data. For a while, I thought the horizontal guys would win everything. And in the last 6-8 months, I've come to the opposite view, that the contextuality of the data and the problem will mean that there'll be tons and tons of vertical solutions and applications. AI democratizes the ability to innovate anywhere in the world equally well because you have the same, more or less, tools. Yes, maybe mythos is being kept for America, but generally speaking, someone in a small town in India has the same tools that someone in Seattle does to innovate and create a company or a solution, or in a university in the South. So I actually think it's all about, to pick up your point, it's also about the moral will, the entrepreneurial passion, the fierce scientific passion we bring to ethical questions today that are fierce, that are existential, that are short-term, and we need to take this new technology and apply it. I mean, would I rather it wasn't in the room? I have no idea, because the range of outcomes is like this. You heard Benji talking about existential risk for the whole species in 6-7 years. But if it's here now, let's use it powerfully, and that can be done in the global south as much as in the north, because it's the application layer that really matters to solving these problems.
Thank you. Stelio, correct me if I'm wrong, I'm not, but just to say that artificial intelligence will be deployed regardless of its carbon and water footprint. Okay, so what criteria, according to you, should guide us in deciding whether a specific AI application is scientifically and environmentally worth its cost?
Okay, difficult question. Okay, first, from the scientific point of view, we need to not overuse AI and use it with, have in mind, train ourselves basically to help us add to the human knowledge. That's the first criteria, not refrain or surpass this optimization trend of use of AI. Second, if we want to have an impact result from using AI, we need to go to large-scale AI by default. This means big data, HPC usage, people working on it, understanding the problem, all these kind of things, and be sure that this will be environmental friendly, or let's say that the balance between using AI and have this all minus negative impacts, but the result will be in the balance of positive. We need the framework, basically. We need a standardized framework to assess the technical part, water, everything, energy, in order to be sure that we have a responsible use of AI focusing on climate environmental problems, basically. Or, in other words, make every gram of CO2, water molecule, or joule of energy count towards genuine knowledge and solving the climate problem at that case for the planet.
Thanks. So, 30 seconds for each one of you. Last question. Imagine we meet again in 2035. What single development would convince you that AI has become a net positive force for the planet? You lady first.
The numbers.
Single one. 2035.
2035. What will convince me?
What single development would convince you that AI has become net positive force for the planet?
The numbers. I need to see, it's a math problem, right? It's about the numbers. I need a measurement layer that is so robust that we have seen that it is net positive, not net negative with the numbers. And the reason I push for that layer is because we cannot actually enjoy its benefit, back to the existential crisis, without knowing what the cost is.
The environmental crisis is not the only crisis around us. So the net benefit or trade-off, firstly, back to Benjamin's point, one good thing would be if we are still around as a species in 2035. That would be useful. We have, it's a multi-dimensional chess game going on here. Of the Rockstrom planetary boundaries, I'm only focused on one, which is climate. There's the ocean, everything's a mess. So the numbers, to your point, that allow us to believe we've landed this completely unstable system into numerical stability. In my world, that means getting the GHG curve to bend with the help of AI towards a sustainable climate future.
Thank you. And you, Stelios?
I'll be more fundamental in terms that everything ends up to the energy source. So a progress in the energy source to refrain from fossil fuel, that goes for AI and for everything. In green transition, not only for Europe that tries to do it, but for bigger contributors of the world, basically.
Time flies by. We reach to an end. Thank you very much for this discussion.